Hey guys, welcome back. All right, so a little change up here. This, I'm not sure what the deal is with this yet. So the only reason I needed this is because I needed the file size. So that's what this video is about, was the file size. Because, as everyone knows, when it came to this function here, where are you? A little bit further down, and right, nope, close, right there. So when it came to reading the file, we needed to dynamically change the file size. Well, because I didn't want it, we should never have to use a fixed file size, okay? So what I've done in this particular thing is updated this README. And you'll notice it's slightly different, but these two lines here, I added also to see what the file size is here based on what we get with this here. Now what I've done is I've added this function that needs the file handle first fed to it, and then it returns the file size. So it's this function right here. Now what it's doing is it takes the file handle, goes in there, opens the file by setting a position on it. And it sets it to the max amount that you can do, which in this case is that. That's the largest. I mean, that number's so big, I don't know anybody that's going to have a file size that big. I mean, we're talking in the petabytes, maybe even larger, I don't know. The point is that's a huge-ass number, okay? So then what it does is it sets the position all the way to its end. Now, what this means is that it'll only go so far as to the end of the file. So when it's done, when we go into the next and we go to get the position, we're already at the end of the file, which means that we're not maxing this out, obviously. So it's only going to go as far as the file size itself, which means once we get the position, we're getting back the actual position at the end of the file, which represents the actual file size. And that's kind of how this works. So once we get that, then we reset it back to the beginning of the file, because if we're going to use it somewhere else, we don't want to leave this hanging. We want to be able to set this back where it should be. So this sets it right back to the beginning of the file, and then we just return the file size. And it's 64-bit, but we leave it as uint_n just in case for 32-bit machines. But in our situation, this is a 64-bit. Hence what this is all about here. Now, this could probably be changed if this is 32-bit. So keep that in mind. I just didn't bother, adding that extra line to decipher which one it would be. Let's see. Okay. Now, once we grab this and it sets up the file size, well, you already know the rest. We just basically allocate the size that we need for it, and then we go ahead and we read the file based off of how many bytes we actually need to read in. And that's it. There's not much to that. And of course, well, we'll get to that in just a second. So in here, we are reading the file right there, and it will print the number because I've kind of hard-coded that info right. Where did I put that? Right there. It's inside the README. This will be deleted. I've just only added this temporarily just so that we can make sure and see for this demonstration, okay? So that's not necessarily supposed to be there. All right, so we'll have this. It'll delete the test file after it prints the number of bytes that's there, and then it'll remove the directory that we create. So in here, this is what's been added. Let's scroll down. Here it is. This right here. Now, keep in mind, even though I'm not actually utilizing this, I went ahead and left this info in here, and I'm still not convinced something. I'm wondering if something with this number is wrong in the PDF. This number, this GUID number, is actually directly from the actual PDF. So I'm starting to wonder if there's an issue with that. The other issue is it could be the memory type, because the actual PDF is not very clear with this when it comes to the EFI file info. Okay. So let's scroll down and show you more of what I'm talking about. So we'll really get down in here, and it's right below, right here. So we have this token. Now the token is used for, where are you? Right here. It's used for these extras, which is actually the one with the EX behind it. Okay, that's where that comes in handy. That's why I've added that, because I went ahead and filled this in. Now remember, this was the last thing we could do. And by the way, these are the two functions that we're using to get the file size. You'll recognize them. Okay, so that's where I got these. Okay, but the rest of this I went ahead and filled in. And this is the little booger that's giving me issues right now, the get info. I'm just not sure what the deal is with that. So it's this line right here. And I mean, I keep thinking I'm filling this in right, but apparently I'm not. Yeah. So I'm going to have to come back to that. I'm not even sure if I want to tackle that. I mean, I do. I really do want the ability of that, but I don't know if it's something that's necessary at this time. Really, I'm not sure if we even need that. Anyhow, I can't think of anything else. I just filled all that in. This is the attributes, and there's the file size that I was actually trying to pull from. There's the physical size on the drive. This is how much space on the physical drive it's taking up. And this is the actual file size in bytes. Now, physical size on the drive, which means when it comes to sectors, if you say you write a 510 byte file, right? Well, on the way that the drive works, or an operating system works, is it goes by sectors. So if you write out 510 bytes, then it's going to automatically fill in an extra 2 bytes to equal 512, because that's one sector. That's how even Windows works. When you open up a file, for example, let's say we go here and you go to properties. This is the actual amount of bytes, but this is the actual amount of sectors that it uses. And since I'm on an NTFS formatted drive, it does it at 4K per sector. It doesn't do it, it doesn't read and write as 512K per sector. And due to the fact that I'm using, so that means that I'm actually using up physical space of 4K just for this 1320 bytes. So keep that in mind. That's the way it was designed. Okay, well, on a FAT32, it goes by 2048, which is a 2K. But because of the drive that I'm utilizing, when we go to the drive here, you'll notice this is a 40 meg drive. A 40 meg drive cannot handle a 2K sector. So this is why I had to choose 512, because 512, for me to format that as a FAT32, I had to use the 512 bytes per sector instead of 2K per sector. So that's why this is the way it is. So let's say that if I had done it as 2K, which is 2048, then you're looking at, 2K, 2048 bytes per sector for something that's only 510 bytes. That's a waste of space. So yeah, this is why these kind of things exist. And so physical size on a 2K per sector, anything that's like 100 meg or bigger for FAT32, it's going to be 2K. All right, I think I'm kind of bashing it in the horse's head here. So we got the physical file size, we got the regular file size and the physical size. We got the create time, last access time, modification time, attributes, and of course the file name. And of course this is a string which is 16 characters. Now, I wrote this here because this is important. This is a dynamic based on what we are looking at, meaning that if your operating system, like in Windows, is it Windows? I think in Windows, we can hold 512 bytes. I think that's right. In the old DOS days, it was only 256 bytes. All right, so you may be thinking, yeah, but the short file names is only like 8.3. You know, you have a test dot, I'm going to do test twice dot text. That's considered 8.3. But in newer versions of Windows, you have this is my test dot txt. Well, this is considered a long file name. All right, so when we're talking about 256 bytes, we're also including the path, or in this case, like that. So you have to include the full path, like C:\/ my file storage \, and then the file. This actually, the whole thing actually counts toward this. So if you go further than 256 bytes, well, it's going to truncate this, and it just simply won't work. So in Windows, I believe, I could be wrong, I think it's 512. It might also be 2048, but I still think it's 512. Anyhow, we leave this blank here because it's supposed to be filled out based on the operating system. So we leave this as is. Let's see, what else? Now, the difference between short file names and long file names is pretty well explained. The only difference is you're not allowed to use long file names. That is actually patented by Microsoft, and it is against the law for you to use it unless you get written permission from Microsoft to use long file names. So keep that in mind. All right, so now that we've got all this out of the way, let's actually test this out. So let's see here. I'm going to close that, close this, and we're going to leave that open. So I'm going to minimize. You already know what this is doing, so I'm going to go ahead and close that. Go back into the source code. There we go, and compile. And we should be good to go. Got all that. All right, good, good, good. One more. Go ahead and open that. Come on, there you go. And do that. Okay, hit the space bar. Now, so successful, everything is successful. Now you notice getting the file handle, and then we have the file size because we grabbed the file. We're listing as 7 bytes. Now, what it's done in around this section here is that's when we were going out and figuring out the file size. And of course, everything else is successful. Now, check this out. Now we're going to go in here and change that just so you can see that it is dynamic. So let's see here. Here it is. This is what, now if you count that out, that's actually 7. All right. So hello there, YouTubers. All right. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, so we should get the number 27 when we go to compile this. I'm going to go ahead and just shut that down. We'll go ahead and do that. There we go, and that. Wait, and done. And here we go. All right. And 27 it is. There you go. So now you can see the file size is working. And really, that's really all we needed for everything else we're about to do. So I'm just happy that that's done. I'm still a little disappointed I could not figure this out. So what I did is I just shoved it way down the line because I'm just still not convinced we even need it yet now that I've figured out the get the file size aspect of it. So we may never get to that because honestly, I don't know what's wrong with it. And it could be because the version of the EFI that I'm using in VirtualBox may not be up to date. I really don't know. So it could be anything. So eventually I'll figure it out, but just not right at this time. I want to hurry up and get up to resolutions and things like that. So, all right. Well, thanks for watching, and I will see you next time.